So we can start now, guys. So as I told you in the last lecture that we are going to have today, we're going to have, I'm going to teach maybe for 1 hour or so, and then we're going to complete lab 1, lab 2. Okay. Also, we have a quiz. You should have received my email about assignment 2 and lab 3. Okay. Okay, so let me open this one. Okay, so here, guys, in this chapter, in chapter 2, I'm going to teach assembly instructions. I divide the assembly instruction as you see here: data transfer instruction, arithmetic instruction, loop, shift, rotate, and so on. So I divide it into sections as you see here. Okay. So today I'm going to start teaching data transfer instructions. As I told you in the lecture, in the last lecture, data transfer instruction are actually similar to equal when you do something like I is equal to 2 in assembly in C language. Okay, so in C language you can do something like that. I is equal to 2, or you can do something like that. I is equal to J. Okay, so here how can we do the same thing in assembly? We don't have equal, so there is no equal here in assembly, right? Here I or J, it can be a register or it can be memory location to immediate value, okay? That means I should have an instruction so that one register is equal to register is equal to memory location equal to register, yes, okay? So they are an instruction. We don't have equal here, very clear, okay? So that's what I'm going to teach here in this section. So we have here load instruction. As I told you, load instruction is used if you want to copy memory location or immediate value. So if you want to copy memory or immediate value to one of the registers, you can use load. Store is used if you want to copy a register to memory location. Move is used if you want to copy memory location to another memory location. When I say memory location, I mean it can be, I can copy byte to byte, or I can copy word to word, as you will see right now. Also, we have an instruction, we call it transfer. So transfer is used if you want to copy register to register, okay? So I'm going to teach you this instruction. They are very easy. I think I already used some of them before. So you are going to be somehow familiar. So let's start. Okay. Also, we have exchange instruction. So exchange instruction, it is similar to transfer. It works between two registers, but you will see right now, exchange, transfer, you copy one register to register, but actually exchange is going to do like a swap. You swap two registers, as you will see right now. Okay. Anyway, so here I want to tell you something here. When you say, for example, transfer, this is an instruction, this is transfer A, comma B, right? So what this one is doing, you actually copy register A to register B. Register A, we call it source. Register B, we call it destination, okay? So after you execute this instruction, the source should not change, but the destination should change. For example, if A is storing 20, B is storing 70, right? So after you execute this instruction, A source does not change, but I'm gonna copy this 20 to here. So where is this 70? Where is this 70? It is gone because you overwrite it, okay? Same thing, this is similar to what we do here when I say I is equal to J, okay? So the old value of I is gone, right? Here actually you copy J to I, right? Anyway, so these are all the load instructions we have. You can say load accumulator A. I told you the word accumulator, we use it for A, B, and D. accumulator, it's a register, so load register A, and then you should put here either immediate value or memory address. Okay. For immediate value, as I said before, you have to put here hashtag. Okay. For memory, as I explained before, for memory we have 4 formats for memory. As I explained before, you can put a number like this one. You can put something like 1, X or 0, Y, and so on, or it can be something like that. Also, as I explained before, it can also auto increment, auto decrement. So it can be 1. It can be 1. I'm not sure why it's not right. Oh, the bin itself is not working. Yeah. The bin itself is not working, but look, yeah, I can do this. So anyway, 1, for example, here plus X. Okay. When you use this plus or minus, I don't know why the bin is not working. I think we need to charge. Yeah. Let me see. Anyway, I think the pin is not working. Okay. So, this is how this instruction is. So this instruction, you can say load accumulator A, and then you put here immediate value or one of the memory format. So here what happens, you copy a byte from here and put it in register A. Okay. We have another one here, load register B. And same thing here also. So here you need to you have to put here only one operand. You need to put here one operand, okay? Because you copy this operand from here to here. This is the source, this is the destination. Okay. Same thing, you can say load B, okay? But here you copy a byte. We have also load D, okay? Load X, load Y, but it's exactly similar thing here. This instruction need only one operand. This operand can be immediate value or memory. Okay, same thing. But here you copy actually a word. Here you copy a word, you copy a word. That's all what we have. That's all what we have for load. Okay, guys? Easy, right? So here, these 2 instructions, they copy bytes. These 3 instructions copy words. Okay. For what about to store? Exactly same thing. I'm gonna repeat the same instruction here, but for store. But remember, store here, this register is going to be the source and the destination is going to be a memory location, because the store is used if you want to copy to a memory location. That's why, that's all what we have here. It's the same thing. We have store A, we have store B, we have store D, store X, store Y. That's all what we have, right? And you have to put here a memory location. You cannot put for sure immediate value, because you have to copy to a location, memory location. And again, here for memory location, you can use any format from the 4 formats I taught for memory location. You can use any one of them. Here you copy a byte, which register A, you copy it to a memory location. You copy a byte here in register in memory location, register B to memory location. You copy a word, which is register D, to 2 memory locations here. Also here you copy a word, here also you copy a word. Okay, easy, right? Any questions? Okay, so this again, this all the instructions we have. So I want to tell you here, guys. First of all, you don't need to memorize these instructions, okay? Because for any exam or quiz, you should have the slides. So you don't need to memorize all these instructions. Also, here in the slides, I use tables like this table in order to, in this table, I just summarize, or I put all the instructions here, okay? So that it's easy. If you forget the spelling of this instruction, you can just go to the table and you can find them here in the table, okay? Now, what about transfer? Okay, again, I told you transfer here, you should copy register to register. Don't confuse yourself. Transfer, there is no memory. Just copy register to register, okay? So the instruction we have here, transfer, okay? And then you have to put one register here, comma, you have to put another register here. This is the source, this is the destination. Very easy. You just copy a register from here you copy this register to this register. Okay. So, for example, you can say transfer A comma B. So you can copy A to B. Is that okay? By the way, so you can use it this way, or we have also another instruction. So this instruction transfer here, actually it needs two. This instruction, it needs two operands, as you see here. One operand here, one operand here. Okay. Here we have also another instruction, TAB. Okay. This instruction is inherent. This one is gonna copy A to B. So it's the same thing. If you want to use TFR and then A comma B, it's the same thing if you use TAB. Same thing. They are doing the same thing. Okay. Same thing. We have TBA. It's one word. It's inherent. Okay. It's the same thing if you say transfer B comma A. Okay. Also we have TSX. If you're gonna copy S here, this is the stack pointer. I didn't talk too much about the stack pointer because I told you I'm gonna use it later. It's not a general purpose register. This is gonna be used only for stack, so I need it later. So you can see it like BC. Okay, it's a register, but it's not like X and Y. I'm gonna use it all the time. No, it's not like that. Okay, it has a special functionality. I'm gonna talk about it later. Okay. So also we have TSY. Here you copy the stack pointer to Y. TYS you copy Y to S stack pointer. Also we have TAP. Okay, what's P? We don't have a register P here. So this P, it means the flag register or CCR. So this instruction actually you copy A to the flag register. You can copy B to the flag register. Okay, guys. Again, don't worry. You don't need to memorize anything because I put all of them here. If you see here. Yeah. So here, as you see here, guys, we have TAB. This is inherent. It does not need any operand. We have TAP. So we have all the instructions here. I already explained. Very, very easy, right? So we have TFR, as I mentioned, and this one it needs two operands. One from these registers and one from these registers. Okay, guys, any questions? Easy, right? Again, don't confuse. Transfer is used only when you copy register to register only, right? Very easy, okay? So, I'm gonna tell you something interesting now. So you are telling us for transfer, I can select one of these registers here as a source, and I can use one of these registers here as a destination. Okay, so I'm gonna tell you something interesting here. Can I transfer? Again, transfer means copy. Don't be confused. Transfer means you copy. Okay, can I transfer or can I copy a byte? So I can select here A and I can select X here. Can I copy a byte to a word? Or can I copy a word to a byte? You understand what I'm saying? It should be no. The answer should be no. Because when you copy, they have to be the same size. I can copy byte to byte or word to word, right? Unless you are going to do it in a different way. Yes. Okay, so what I'm saying here, yes, you can copy a byte to a word. And you can copy a word to a byte. How? Yeah, I have to tell you how because it doesn't make sense because the size is different. I'm going to tell you how. So, for example, how can you transfer or how can you copy a word to a byte? So you can say transfer and you can put here a word and you can put here a byte. If you do this way, so this is a word, as you see here. When you copy a word to a byte, actually what happens, you only copy the least significant byte. So I'm not going to take all X. I'm going to take only the least significant byte. I'm going to copy it to A. Now it makes sense because you are going to copy byte to byte. You understand what I'm saying? So it is possible to, I can say like transfer word to byte. Okay? But when you do that, actually, you have a word, right? This word is 2 bytes. Actually, what you are going to do, you are going to copy the least significant byte to A. Okay, guys? I'm going to, so how I can need something like that? How I can need something like that, okay? I'm going to give you one quick example. We are going to use it, you are going to use something like that in this course. I'm going to explain it quickly, but later it's going to be clarified in this course. For example, guys, look here. if I want to display number 372 on the LCD, okay? So this is a binary number. I want to display on the LCD 372, right? As I'm going to explain later, the way we are going to do it is, number one, I have to extract the digits from here. So I have to get 2, I have to get 7, I have to get 3. It's because I have a binary number, right? 10, 10, 10. This binary, from this binary number, I have to extract 372. And then I have to transfer these numbers to ASCII. And then I'm going to send them to the LCD. You got what I'm saying? So you have a binary. And again, if you don't fully understand it, don't worry. We're going to do it later. Don't worry. Okay? So again, I have a binary number like 372. I write it in decimal, but actually it is binary, 101010. Okay? So I want to display this number in decimal on the LCD. The way we are going to do it is, number one, from this binary number, I need to get the digit. I need to get 273. Okay? Then every digit, I'm going to convert it to ASCII code. Now you have 3 ASCII. I'm going to send this 3 ASCII codes to the LCD so that you can see 372. Okay? Anyway, so if you have a binary number like this one, how I can extract? So if you have, as you know, 1, 1, 1, 1, 1, 1, 1, 1. This number is actually 255. So if I want to display this number on the LCD, all what I have to do, I have to send to the LCD 32 to the LCD, and then 35, and then 35. Okay? 32 is the ASCII of 2, the ASCII is 5, the ASCII of 5. Okay? So given this number, how can you get these 3 ASCII codes? Again, as I'm going to explain later, the way we do it, when I divide this number by 10, when I divide it by 10, I'm going to get quotient, which is 25. I'm going to get the remainder, which is 5. So every time, and then I'm going to get this one divided again by 10. So every time I divide by 10, I'm going to get 1 digit. Okay, anyway, so this is the main idea. So if you have a binary number and you want to extract the decimal numbers, okay, every time you divide by 10, you are going to get 1 digit. Okay, so then I'm going to get the quotient, divide it again by 10. Anyway, so that's what I did here. So for example, if you have 372, I'm going to divide it by 10. The quotient is 37. The remainder is 2, right? As I'm going to explain later, this division, when you divide, the remainder is stored in a word. That's what I'm going to teach you later, okay? When you divide, automatically this division, the remainder is stored in a word, okay? So after you do the division, you have a word here. But because I divide by 10, the remainder always has to be less than 10. Remainder always has to be less than 10. That means I store it in a word, but actually I know the number is going to be in the least significant byte. Okay, so the remainder will be here and zeros are going to be here. Okay, so because this number, the remainder is always below less than 10. Okay, so now I have a word, but actually the number is already here. So if I have something like that, I can transfer. I can just, so in this case, I'm just interested in this byte, so I can take this byte and then I can use it later. Again, guys, I don't want to confuse you. What I'm saying here is, we have an instruction. This instruction, if you have a word, you can read, actually, you can read 1 byte from this word. You can put it here and you can read it to a byte, okay? I'm just giving you one example why I may need to do something like that. Why? I give you example, okay? In this example, I told you, I divided by 10, so, but this division, automatically, this division is gonna store the result in a word, okay? So all what I'm gonna do here, so my number is here, so it makes sense only to take this byte, and I don't care about this byte. Anyway, this is just, okay, guys? So now I explain how can you copy a word to a byte, okay? So here, when you put a word or byte, what happens? What happens, actually, you are gonna copy the least significant byte, not the whole word. Doesn't make sense, for sure, to copy 16 bits in 8 bits. Doesn't make sense, right? Is that okay? Now, I'm gonna give the other case. The other case is, how can you copy a word, sorry, a byte to a word. Okay, how can you do something like that? So yes, I can do something like that. For example, I can say transfer A to X or B to Y. You get what I'm saying? So first of all, is that a problem if you have a number stored in a byte? Can you store it in a word? Yes, for sure, because it's just a bigger space. Yeah, I can do that. It's not a problem. You understand what I'm saying? So if the number can fit a byte, for sure I can store it in a word. That's just a bigger space. You get what I'm saying? However, there is a small trick here I want to tell you about. So the idea is that I have the number in a byte. So I have a certain number here, whatever the number is. Now here I want to put something here in the word so that I'm going to get the same number here. If the number is 100, I get 100 here. But just as stored in a bigger space. You got what I'm saying? This is the idea here. I don't want to change the number. It should be the same number, but stored in a bigger space. Okay. That's what we call extension. So here we call extension. Extension means you extended a byte to a word. How I can do that? Someone can tell me, yeah, that's easy. All what you have to do, this byte can come here, right? So this byte, for example, is 7. Yeah, so now it's 7, and then put 0s here. Is that right? Just put 0s here, right? Makes sense, right? So I'm gonna take the same byte here and put 0s, because 0s on the left, they don't change the numbers. Are you okay with that? Okay. No, it doesn't work. It doesn't work this way all the time. It doesn't work this way all the time. You know why? Especially if you have negative numbers. If this number is negative and then you put 0s, you are going to have a completely different number. Because at least you can think about it, it's going to be a positive number because you put 0s. Okay? So it's not all the time you have to put 0s on the left. So how can we do it? I'm going to tell you quickly how can we do it. So here, again, what extension means? Extension means I have a number. This number is stored in a byte. I want to get the same number, but stored in a word. Same number. Okay. So what you have to do is, yeah. Okay, missed it here. Yeah, so here I'm explaining here, guys. Actually, the way we extend it is different if the number is signed or unsigned. Okay, so if the number is unsigned, just to put 0s on the left, and it should be okay. Again, so if your number is this, how can you do unsigned extension? Okay, I give you example here. You have this number 11111111. This number should be 255. Is that okay? Unsigned number, 255. So if I put 0s on the left here, still I have 255. You got it? So again, if the number is unsigned, just put 0s on the left. You are going to get the same number. It should be okay. Okay. If this is 255, this one also 255. Okay. Now, if the number is signed, so it can be positive or it can be negative. In case of positive, you just similar to what we did here, just to put 0s in the left and it's going to be correct. I give you example here. You have this number 110000. So this number is number 3. So if I put 0s on the left here, still I'm going to get 3. Is that okay, guys? Now, if the number is negative, so you have to put 1s on the left here. The 1s don't change the number. In case of negative numbers, if you put 1s on the left, don't change the number, you will get the same number. Okay, I have example here. The example, if you have 11111 this way, this is -1. So if you keep putting 1s here, it's still -1. You didn't change the number. However, if I put 0s here, now this number becomes 255. So the original number was -1, okay? And when you extend it, you changed the number, you made it 255. So let me tell you the conclusion. The conclusion is, number one, what do you mean by extension? I I have a number stored in a byte, and it's the same number. I want to store it in a word. That's the meaning of extension. And there are two cases. If it is unsigned, just put zeros, and you are okay. You are going to get the same number. Okay. If the number is signed, in this case, we say just repeat the signed bit. So if the signed bit is 1, put once, or the signed bit is 0, just repeat the 0. Okay. Or I can say it in a different way. If it is positive, put zeros. If it is negative, put ones. Very interesting, right? Because, so in negative numbers, usually we know if you put 0 on the left, 0 are not going to change the number. That's true. But it's true in all the cases except negative numbers. In case of negative number, if you put 1 once on the left, you get the same number. Is that okay? Any questions? Okay, so let me return to here. When I say transfer byte to a word, so here I'm going to put byte, I'm going to here a word. So this one actually is going to do extension. So I'm going to take a byte, I'm going to extend the byte to a word, store it in a word. Is that okay? So this byte here, the byte in register A is going to be extended to a word, and then I'm going to store it in X. Is that okay? So now you need to ask, okay, but we have two types of extension. Which one this instruction is going to use? This instruction is going to do signed extension. Is that okay? There is another instruction I'm going to explain later, can do unsigned extension. So in your program, you know if the number is signed or unsigned. Okay. So if your numbers are signed, you can use this one. This instruction, it's okay. This instruction is going to do signed extension. But if your numbers are unsigned, you have to use other instruction I'm going to teach later. Is that okay, guys? So now, again, number one, you should know transfer, how transfer works. Okay, transfer means you copy. Also, I explained two different cases. So when you transfer, how can you transfer or how can you copy byte to a word or word to a byte? Okay, guys? Okay, the next instruction I want to teach, we call it exchange. So exchange is different from transfer. Or okay, so this one is gonna like swap. So this one is not gonna copy swap. Okay, as you see here. So for example, when I say same thing, you can say here exchange, and then you put here a register, comma another register. Exchange only used for registers when you want to swap register to register. Okay. So for example, I can say something like that: exchange A comma B. So you actually A is a value of A is going to go to B, the value of B is going to go to A. I give you numerical example here. If A is storing 20, B is storing 70. After I execute this instruction, now A is 70, so 70 is going to come here, 20 is going to come here. Is that okay, guys? So here, the two registers are going to change. Before, we have source. The source does not change. The destination, it changes. But here, both of them should change. Any questions? Okay, so here I'm explaining. Let me put this one here. Here I'm explaining if you exchange, how exchange is how it is different from transfer. For example, look here, guys. When I say exchange A comma B or B comma A, it's the same, right? No difference. Both of them are going to do the same thing, right? However, if you say transfer A comma B, is completely different from transfer B comma A. Because in case of A comma B, you actually copy A to B. Here you copy B to A. You got what I'm saying? But here it doesn't matter because you have to copy B to A and A to B as well. Okay. Any questions? Okay. Also, can I exchange byte and byte to word or word to byte? Yes, you can do that. How? So if you have here a byte and you have here a word, how I can do exchange here? Okay. Yes.
So when we do this exchange and transfer, we're doing the actual value of the register, not the address, right?
Registers don't have addresses. Registers don't have addresses. What I say? I mean, when I say you copy a register, I mean the value of the register. You can understand? I know this would be confusing to students when I talk about memory location. When I say I copy memory location to memory location, actually I copy the content, right? I don't copy addresses. I don't care about addresses. You know what I'm saying? I copy the content. I know this part is going to confuse students, the location. Most of the time, I think it's mostly we mean the location. Sorry, the content of the location, not the address. Okay. So here now, if you exchange byte and word, how this works? This is similar to what I did before. That means you are gonna copy a byte to a word. How can you copy byte to a word? Extension. So you are gonna extend the byte to a word. Okay. Now, how can you copy a word to a byte? So again, as I explained before, for word to byte, you are gonna take only the least significant byte. Okay. But from byte to word, you are gonna do unsigned extension. So this instruction is gonna do unsigned extension. Transfer is gonna do signed extension. Okay. By the way, I also have a very easy way to do unsigned extension. I have a very easy way to do unsigned extension. How? If I have a byte here in a memory location, and I want to do unsigned extension to this byte. You know how I can do it? Very easy. I can copy this byte to register B. Okay, using store. So I can use the store instruction. I can use a store instruction to copy this byte to register B. Okay, and then I can put 0 here in register A. By this way, register D now is unsigned extension to this byte. You got what I'm saying? Just put 0 in the left. Again, all what you have to do, number one, you have to copy this byte to register B using store instruction. Number two, you have to clear register A. Now, register D should be the unsigned extension to this byte. Okay, guys, is that okay? Also, in addition to exchange, we have this instruction, guys, XGDX. So this one means exchange D to X. So this one is the same thing if you do this way. Okay, whatever you like, just they are going to do the same thing. If you say exchange D comma X, or you can put this way. But this one is inherent. Inherent means you don't need to put operand here because the operation and the operands are together here. Okay, so you don't need to put operand here. But here, for exchange, you have to put two operands here. Okay. Also have another one, exchange D and Y. So this one you can exchange D and Y. Either if you want to use this command, totally fine. If you want to use this one, totally fine. So both of them are going to do the same thing. Okay, guys? Okay, so if you, again, if you come here to, don't worry, if you come here, you can find in this table, I summarize all the instruction here in this table, okay? We have this instruction. This one is similar to transfer. This one is called signed extension instruction. It's similar to transfer. This one can do also signed extension. So let's have examples here. I'm done with the instruction. Only one instruction is left, move, when you copy. So I explained to now, how can you copy register to register? How can you copy register to memory location or memory location to memory? I'm going to have some examples here. I want to tell you something interesting and very confusing to students, but you have, if you understand it, you will be okay. Look at this very confusing example. Look here. When I say transfer A comma X, I have just explained it right now. So this instruction, you should copy a register to register. Okay. So A comma X is actually two operands, and they should be registered because this instruction, what should be after this instruction, it should be two operands. Okay. So you copy register to register and no memory here because you cannot use memory with transfer. Okay. However, if I say load register B A comma X, look here, this one is A comma X. This one also is A comma X, but they are completely different. Completely different. This one, these are two operands to register. You copy register to register. This one is a memory location. This one of the formats of the memory location. So actually here, you are gonna copy a byte from a memory location and put it in register B. So this one means a memory location. It is only one operand and it is only one memory location. Which memory location? The memory location pointed by X plus A. So I'm gonna add X plus A to get the address, and then I'm gonna get byte from there. Okay, guys? So A comma X here, completely different from A comma X here. How can you know? Very easy. I can know from the instruction itself. This instruction, what should come after this instruction should be 2 registers. Okay, they have to be 2 operands, 2 registers, no memory, no memory. Don't confuse yourself. No memory. After this instruction, it has to be memory. It has to be memory or immediate value. Because there is no hashtag, it's not immediate value. So it has to be memory. And it has to be only 1 operand. That's why this one is only 1 operand. Okay, guys, any questions? Okay, I think in test one in one semester, I asked the students to exchange a byte at the memory location 1000 to a byte at the memory location 2000 or 200, whatever. Okay, exchange a byte to byte. So what I meant here is here 1000, here 2000. So what I meant, this byte has to come to here and this byte has to come to here, right? So I want to exchange this byte to this byte, not address by address. Usually we don't do operation on addresses. I do operation on the content. Okay. So I want to exchange this one here and this one here. Some students did this way, exchange 1000 and 2000. For sure, this is completely false. Okay, guys. Why is completely false? Because we don't have this instruction. We have exchange, but what you have to put here should be registers, not memory location. So exchange cannot do exchange to memory locations. They have to be registers. Is that okay? That's why this is wrong. Okay. So okay, if this is wrong, because exchange has to only or can only be used for register. If it is wrong, so how can I solve it? This problem. Okay. First, we don't have one instruction to do this. So we don't have one instruction to do this operation. That doesn't mean you cannot do it. No, I can do it, but you can use multiple instructions, not using only one instruction. Okay. So for example, and that's what I'm going to explain right now. To do that, number one, I can load the value at 1000, store it somewhere, for example, in register A, and then I can use move instruction to copy memory to memory, and then the value of A I can use store to put it in 2000. You got it? So I need to use something in the middle, like this. Move, you copy byte to byte. Sorry, number one, I have to store the value of A of 1000 before I change it, and then I copy byte to byte, memory to memory, and then the value of A, which is storing the old value for 1000. I'm going to put it in 2000. Is that okay? So I can do it, but I have to use 3 instructions. I have to use load first, move, and then store. But this instruction is not going to work. Okay. The last instruction in data transfer instructions, the last one is move instruction. Okay. Move instruction, again, it is used if you want to copy memory location to another memory location. So we have two types of this instruction. One is called move byte, move B. The other one is move W. So here, this one is used if you want to move, if you want to copy a word. Okay. And then here, this one, there should be 2 operands here. There must be 2 operands here. Okay. 2 operands, not 1, 2 operands. You actually copy the first operand here to the second. So this is the source, this is the destination. Okay. So here, it can be immediate value. You can copy immediate value to a memory location, or you can copy memory location to memory location. For memory here, you can use any one of the 4 formats I explained before. I'm going to repeat them again. I explained several formats for memory. When you see something like that without hashtag 1000, this is memory. When you see something like that, 0,x, 1,x, this is memory, right? When you see something like that, A,x, 1,x plus, or 1 plus x. If you see any one of these is memory, right? So you can use any one of these as here. Memory here or memory here, memory here, memory here. Okay, see, so this one is gonna copy a byte from here to here. This one is gonna copy a word from here to here. So what you put here, it can be immediate value. Immediate value is easy. You have to put here hashtag or a memory and then memory. Here also immediate value and memory, but here you are gonna copy a word. Any questions before I give you examples? You don't ask a question, okay? That I'm not sure if this is a good sign or bad sign, because students don't ask a question if they understand it, or also they don't ask a question if they don't understand anything in the lecture. They also don't answer, because I don't answer anything, so I'm not gonna ask questions. You know, hopefully you understand everything. Okay. Anyway, I'm trying to be positive. So anyway, so look here, guys. I'm gonna give you just some examples here. So to understand this instruction, examples are very important to understand it. So here, when I say, look here, guys, move byte, you are gonna copy a byte, and then you put hashtag, comma 1000. What this means? I told you this instruction. There should be two branches here, two branches separated by comma. Okay. So here you are gonna copy number 20 to the memory location 1000. So after you execute this instruction, if you go to memory location 1000, you will see 20. Okay. Because this is immediate value, this memory. Okay. So again, what you put here, the immediate value here, it can be hexadecimal, it can be binary, it can be decimal. It's okay. All of them are okay. Okay. You don't need to convert to hexadecimal, because most of the time I use hexadecimal. Some students think it is wrong to use anything else. It has to be hexadecimal. Okay. So anything they want to do, they convert it to hexadecimal. No, that's not true. You got what I'm saying? You can put any format, and then the assembler is gonna make it binary and store it, because even when I say it's a 20, it's actually stored binary, not hexadecimal. Okay. So anyway, let's have another example. When I say move byte 1000, 2000. What this one is doing, you are gonna actually copy a byte from location 1000 to location 2000. Byte from here to byte to here. Okay. By the way, I can use a variable here. Variable. For example, I can say move counter. Counter is a variable. I already defined this variable. So for example, you have here org 1000, and then you can say counter dc.b, for example, 7. So already I define counter here, and counter is at location 1000. So yes, you can use counter this way, and then assembler is going to replace counter with the number, with the address of this memory location. Okay, this variable. So actually, so it's the same if you do this way or do this way. However, it's much easier for me or for us, okay, to use English names for variables instead of using numbers for physical locations. Okay? And that's what you did, by the way, in C language. In C language, you used to use I, J, but the difference is here, you know the physical location. In C language, you may not, you didn't know, or you didn't even care, but here I can know the physical location. But it's still easy for me to use numbers, names instead of numbers. I give you another example here. For example, if I have something like that, org 1000, then I define two variables. One is called counter dc.b. This is byte, okay, initial value 2, and this one should be at location 1000. So counter should be at location 1000. I dc.b 7. So I is actually physically is going to be at location 1001. You remember in the first lab we have some. So some. This is a name of variable. This variable was physically in location 1000. Okay. So in your program, if you use counter, if you use I, counter is going to be replaced by 1000. I is going to be replaced by 1001. Okay. So for example, when I say move byte 1000 to 1001, so this one you are going to copy a byte from here to here. It's exactly the same thing if you say move byte counter comma I, because actually counter, this one is going to be replaced by 1000, I is going to be replaced by 1001. So exactly same thing. Okay. One more thing I explained last time, and very important, you need it in today's lab and maybe quiz as well. When I say load X hashtag counter or load X counter. When I make this way, students, it's difficult to students to understand it. But when I tell students counter is going to be replaced by a number, which in this case counter is 1,000, so it's going to be replaced by 1,000, a student can understand it. You get what I'm saying? So let's do this way. So I'm going to replace this one by a number. Actually, that's what the assembler is going to do. So this one is going to be load X hashtag 1,000. That's easy, right? So here, hashtag, so, or bound sign, whatever you want to call it, okay? And then, so what happens here, you actually copy, this is this number, 1,000, you copy 1,000 to X. Is that okay? No memory here, okay? But without the hashtag here, it's going to be like load X 1,000. So now I'm going to copy a word from location 1,000, put it in X. Is that okay, guys? Okay. Okay. You are going to need it today's quiz. You are going to need it also. Let's have more examples just to understand this part. When I say move forward, hashtag 3AF2, 1,000. Again, what should come after move is two operands. This is one operand, and this one is a second operand, two operands. So here you are gonna copy this word to 1,000 and 1,001. So that's what you should do here. So if you use this instruction, that's what you will get. Okay, guys. Okay. So next week quiz is gonna be about data and also lab. The lab and the quiz are going to be about data transfer instructions. Okay. So in the quiz, I'm going to give you, for example, an instruction like this one, and then I'm going to ask you what should be in the. I just want to make sure you understand what this instruction is doing. Okay. So giving this instruction, I'm going to ask you what should be in memory location 1,000, 1,001, something like that. Okay. Let's have another example. When I say move forward 1,000 and 2,000, again. What should come after move should be two operands. So this is one operand and this is one operand. So what this instruction is doing, you have to copy a word from this memory location and to this memory location. If you see here, guys, so I'm going to copy these 2 bytes, 1,000 and next one, which is 1,001. I'm going to copy it to 2,000 and 2,001. Is that okay? Because this instruction is going to copy a word, move forward. Okay? Let's have more examples. When I say something like that, move byte, okay, 1,000, 0, X. Again, because move, what should come after move should be 2 operands. So you have to look for the 2 operands. So this one is 1 operand, and these 2 together is 1 operand. Makes sense? Because this is a memory and this is memory. So this instruction should copy a byte from the location number 1,000 to another location in the memory, pointed by X. Pointed by X. Is that okay, guys? Let's have another example. Move byte 0, X, 1, Y. A lot of commas here. Okay, so it's easy. Again, you have to look for 2 operands. You have to look for 2 operands. So 0, X, this is 1 operand. 1, Y is another operand. So you are gonna copy a byte from here to here. This is a memory to memory, right? So you are gonna copy a byte from the memory location pointed by X. This X plus 0, which is X, to the memory location pointed by 1, Y plus 1. Any question? Is that okay, guys? Okay. I just have a couple of more examples and that's it. So I'm not going to teach more than that, but I just want to give you more examples so that you can fully understand this part. Let's have another example. When I say move byte A, X, B, Y, for example, something like that. Again, you have to look for 2 operands and they have to be memory, and the first one can be also immediate value. So here A, X, this is a memory, B, Y is a memory. So you are gonna copy a byte from the memory location pointed by X plus A. Okay, this is the address X plus A. The address here is Y plus B. Is that okay? So byte from here to here. Any questions? Okay, let's have more examples. Okay, when I say, for example, I want to copy a byte 3A to location 1,000. So after you execute this instruction, if you go to location 1,000, you can see the number 3A. Okay. Also, when I say copy a word, okay, 3A to 1000. So actually it's going to put zeros on the left all the time. All the time this one puts zeros on the left, okay? So this one is not about extension. It's about you give me 3A, you didn't put zeros, okay? So it automatically puts zeros. So if I copy 3A here, so any missing, because this should be a word, right? And the word should be four digit, but you only give me 2, so I'm going to put zeros here. If you give me 3, I'm going to put 1 0 here. Anyway, so if you say here 3A in a byte, so it's going to be 3A, but 3 in a word is going to be 003A. Okay. Let's talk about this. This is the example. This is what I told you before. I want to exchange memory location 1000 to memory location 2000. Okay. We don't have one instruction to do that. Okay. So how can you do that? I'm going to do it using 3 instructions. The first instruction, I'm gonna copy the value at 1000. I'm gonna store it in register A using load instruction. Okay. And then I'm gonna copy 2000 to 1000. So now the value of 2000 already I put it in 1000. And finally, I'm gonna store this one in 2000. So the way I can do it is 3 instructions. So number 1, I'm gonna say load 1000. So I have to load A with 1000. Then I'm gonna say move byte, as you see here. Move byte 2000 to 1000. Then I'm gonna store A to 2000. Is that okay, guys? You see it here? This is how I can exchange 2 bytes in the memory. Why you did this way? Simply because I don't have one instruction to do that. That's why I have to use 3 instructions to do it. Okay? The main difference between assembly and C, in C language, you can have too many instructions. In assembly, we have limited instructions. Why? Because every instruction should have hardware. So the more instructions you have is going to be the more expensive as the chip or the microcontroller. Okay. Anyway, so here I explained how can you exchange byte. Here I'm going to repeat the same example. But I'm going to exchange words. Okay, guys. So here I want to exchange the word at location 2000 and the word at 1000. Again, when I say the word at 1000, I mean 1000 and 1001. But for short, I just say 1000. Okay. So the word at 1000, I mean 1000 and 1001. So how can we do it? Exactly same thing. I'm going to repeat the same thing, but you can see here, guys. But this one cannot be a byte. It has to be a word, and that's what I did. Look here. So here I'm gonna take a word from here. I'm gonna put it in register X, as you see here, and then I'm gonna move a word from here to here, not a byte. So you can see I used byte. Here I'm gonna use a word. Here I used register A, which is a byte. Here I cannot use register A. I have to use something else, which is a word like X, for example, or I can use D or any other register, but it has to be a word. Finally, I'm gonna return the word at X in X here to 2000. Okay, guys, you can see it, byte and word. Any questions? Okay. I think I already explained this one, but here I just show you using instruction. If you have a byte here and you wanna it's an unsigned extension of this byte. I told you there is an easy way to do that. I can just take this one, put it in register B, and then I put 0 in register A. So this is the way you can do it. I can say load B with 1000. Yeah. If you do this one, you are going to take a byte from here, put it in register B, and then you can say clear A. I'm going to explain this instruction later. This instruction is going to put 0 here. So if it's the same, you can say clear A, or you can say load A with number 0. It's the same thing. So I can say load A, okay, or copy number 0 to register A. It's the same if you say clear A. Okay. So last example I have here, this is the last one. I'm not going to teach arithmetic instruction. I'm going to leave it to next time. So this is the last example I have here. So last example, and I think you are going to have the same example in the assignment. So this is a problem, I guess, in the assignment. So here I have to erase this array, 5. Every array should have 4 elements, 4 bytes, 4 elements. So here, for example, this array, you have 5, 7, 24. This is array 1. For array 2 is uninitialized, and all what I want to do, I want to copy this array to this array. I want to copy this array to this array, so that after I execute the program, 5 should be here, 7 should be here, 20 should be here, 4 should be here. So I have two arrays. I want to copy one array to the other array. Is that okay? I told you before, if you want to read or write array, we have to use pointers. Okay? But now we have two arrays. That's why I'm going to use 2 pointers here, 2 points. Let me give you an example. Assume this is one array, one element, 5, 5, 5, 5. And this is the second array, 5, 5, 5, 5. Is that okay? I have 2 arrays here. What am I going to do? I'm going to use 2 pointers. X is here, Y is here. Copy this 5 to this 5. Now I'm done. Say increment X, increment Y. Copy the byte pointed by X to the byte incremented by Y. And I can continue this. So here I'm going to use 2 pointers. 1 pointer from each array, and that's what I did. So if you see here, guys, X is here, Y is here. I'm gonna copy a byte pointed by X to location pointed by Y. Okay, and then increment X, increment Y. Is that okay? That's what I did here. So if you see here, guys, org 1000, here I define the 2 arrays. One array is initialized, as you see here. The other array is uninitialized. Is that okay? So now I define the 2 arrays. One is initialized, the other one is uninitialized. And then load X, hashtag array 1. Load Y, hashtag array 2. Very important. We're going to do this one all the time. Very important. I explained last time. This is how can you initialize X with the beginning address of the array. Because array 1 is going to be replaced by the beginning address. Array 2 is going to be replaced by the beginning address. So after I execute this instruction, X is storing the beginning address of this array. Y is storing the beginning address of this one. We are going to do it all the time. I explained last time. This is how can we initialize X and Y. Here I initialize the pointer so that in the very beginning, X is pointing in the first location in array 1, and Y is pointing at the first location in array 2. Okay? And then look what I'm going to do. I'm going to copy 0. I'm going to move byte 0, X, 0, Y. See what I did? So I'm going to copy the byte pointed by X to the location pointed by Y. Is that okay? And then I'm going to say increment X, increment Y, and then I'm going to loop back. Repeat. So this is one iteration. Now I have 4, 1, 2, 3, 4. I have 4 bytes, 4 elements. So this array has 4 elements. So I'm going to make 4 loop. I'm going to loop 4 times. Every iteration, I'm going to copy 1 byte to the other one. Okay? So as you see here, I'm going to copy as a element pointed by X to the element pointed by Y. Increment X, increment Y, and then go repeat again. Then copy, increment, go repeat again. How many times? In this case, 4 times, because I have 4 elements. If I have 100 elements, I would loop 100 times. Is that okay? Any question? Okay. Now I'm going to tell you something. 2 things very interesting. Let's start with the first interesting thing here. The first interesting thing, I'm totally fine if you wanna write this way. I'm totally fine. You can write it this way. Okay. Let me put this one up. So you can say move byte 0, X, 0, Y, and then increment X, increment Y. Okay. However, I can replace this 3 instruction with only 1 instruction here. Very interesting. You got what I'm saying? Very compact. So this 3 instruction, I can do using this only 1 instruction, this one. So this one is gonna copy byte. Okay, as I said before, when I say 1, X plus, 1, Y plus, as I explained last time. So this one, actually, you are gonna copy the byte pointed by X to the byte pointed by Y, and then increment X and increment Y. This is post increment. Okay, so this one is exactly equivalent to these 3 instructions. Is that okay, guys? Again, what I'm saying, if when you write your own program, I'm not forcing you, I'm not requiring you, I'm not asking you to use this format. I'm totally fine. You can use this one. Easy. That's always what I like. If it is long, maybe long code, but it is like it's working much better than writing short code and it doesn't work. You get what I'm saying? So anyway, if you want to do this way, that's fine. But I'm expecting you understand this one. So if I put this one in the slides, if you have this one in the quiz test, I'm expecting you understand that this one is equivalent to these three. Okay, guys? Now, if I want to repeat the same thing here, but here I'm gonna assume the arrays are arrays of words. Arrays of words. How the program would be different. Okay. So number one, here, this part is the same. Load X, load Y should be the same, right? For sure, here it has to be dc.w, ds.w, as I explained before, not B. Okay. Here, when you copy, it has to be W, not B. So you have to move W. So you have to copy a word pointed by X to a word pointed by Y. So here you have to use a W. Also, every iteration, you have to increment X by 2. You have to increment Y by 2. You get what I'm saying? So you have to increment by 2. Is that okay? So every iteration, you have to increment X by 2, Y by 2, not by 1. Okay. Or I can write it this way. So this instruction, I can just write it this way. Move forward 2 instead of 1, 2, comma X plus, 2, comma Y plus. So this 2 means I'm going to increment X by 2. I'm going to increment Y by 2, right? So here, this instruction is actually, you are going to move forward from 0, comma X to 0, comma Y. This is number 1. Number 2, you increment X by 2, you increment Y by 2. Okay, guys? So again, don't be confused when you see something like that. That means I'm gonna copy a word from location pointed by X to location pointed by Y, and increment X and Y. Okay, because this is post increment. It's not pre increment. If it is pre, I would increment first and then copy. But here it's pre. It's post. I think that's enough. Yeah. Yeah. Okay. So next time I'm going to teach arithmetic instructions. Maybe quickly before we take the quiz, I want to talk about the lab here today quickly. Okay, so here, starting from this lab, I'm asking you to write a code. We are going to start writing code, starting from the second part here. So here quickly, so here I'm asking you first, define a byte variable called counter and initialize it with this value. Okay, that's easy, right? Define an array of words. This is the name of the array buffer, and it should store these elements. Also, this should be easy, right? dc.w or ds, whatever you think about how you can do it. Okay, this is just definition. You already have a quiz last week on how can you do this, and this should be in the data section. You know, your program should have 2 sections, or 1000 and then have another or 4000. So here all the definition should be here, right? The program should be here. Okay, and then I'm asking you load register X with the unsigned value, using immediate addressing mode. So I want to load X with this value, okay? And this value is immediate value, okay? Load, any question for this one? Same thing here, load A with this binary value. So again, you don't need to convert the binary to hexadecimal. Don't waste your time. You don't need to keep it binary, keep it decimal, okay? It doesn't need to be hexadecimal, but you have to use the prefix, the correct prefix. Also here, store the contents of register X at memory locations using extended addressing mode. So here I want to store X. The value stored in X, the number stored in X to these 2 memory locations using extended addressing mode. Okay. Load B, I want to load B with the content of this memory location, and I'm asking you to use, for sure you can use extended, but here I'm asking you to use constant offset addressing mode with register X. This is the one like 0, X, 0, X, 1, X, and so on. Okay, so that's what you have to use, constant, X. Okay, so for this instruction here, actually you have to use two instructions here. Number one, you have to set X with the correct value, okay, before you load here. So here it should be two instructions because X is a pointer, so you have to set the pointer before you use it. Okay, so that the address here 0, X or 1, X, whatever, the address should be 2F00. Okay, is that difficult? So the easy way, you can just put 2F00 in X, and then you can use 0, X. Okay. Anyway, also here we have store register B. Same thing. I think this one is similar to this one, but here I'm asking you to use constant register Y. So it's the same thing, but here X, this is Y. Store register A in this memory location, and here I'm asking you to use auto increment addressing mode with Y. So auto increment, pre-increment, pre. So you are going to increment first. You get what I'm saying? So what I have to put in Y, I have to put a value, so that when I increment this value, it becomes this address, right? Because you increment first. Think about it. You get what I'm saying? So I have to put some value in Y, so that when I increment this value, I'm gonna copy to E07. Okay. So here, store register A in this memory location using also offset indexed addressing mode. Should be easy, right? So all what I need from you, you should write the instruction, run the program, and see if the result as you expect or not. Very easy, right? Yeah, just run it and see if you copy this one to here or not. So for sure you can write some code, because if you maybe this memory location does not have a value, maybe you can write more instruction to put some value in this in this memory location, so that you can verify or you can test that this value is copied here. Okay. Load register X with the address of counter. So here I wanna store in X the address of counter. Okay. Here the content of counter, address or content. Okay. Address or content. Address. Okay. One of them should have hashtag, the other one should not have hashtag. Okay. So think about it. Also register B with the content 1000. Load X with the starting address of the array buffer, and then using indexed address mode register X. Load Y with the first element in the array. Okay, 0, X, 1, X, 2, X, as I explained before. Think about it. Here also the same thing here, using indexed addressing mode with register X. Again, here also I explained this one several times. What is the difference between load X buffer and load X hashtag buffer? Okay. Do you need any help? Any questions here before you? Okay, great. So again, all what you have to do based on what I told, just write the instruction and then see if the instruction is correct or not. We are going to have a quiz just for a few minutes. I want to do something quickly, guys. I'm writing here. These are the initial values, okay, before executing every instruction. So when you execute one instruction here, and you want to know what is, and you need, for example, register A. What is the value of register A? Don't take the previous one, right? Just take this one. These are the values before every instruction. So this is not one piece of code. It's not one piece of code, okay? So if you need A, don't go back and see what was the value of A here. No, right? Next step is going to be one piece of code, but this one no. Okay, but here